So today we are going to do substitution and scattered graph. So substitution is when you replace numbers with letters. For example, now they give you an equation or they give you a formula. So when you replace the letters in the formula with your numbers, that is called substitution. So we're just going to dive straight into it. Oh, sorry, let me share the screen. I was like, share screen. Sorry. So, is the first part of it will cover substitution, and it will also cover scattered graph. So, I said earlier, substitution is when you put letters, when you put numbers, substitute numbers inside the formula. You change the letters with numbers. So, for example, now the most common question in functional scale. So here's the formula to convert temperature in degrees Fahrenheit to temperature in degrees Celsius. So this is the formula. We will say C equals to 5F minus 32. Then you divide everything by what? By 9. That's the formula. So F represents temperature in Fahrenheit. YC is the temperature in degrees Celsius. So it's, for example, now if they ask you to convert from Fahrenheit to Celsius, you just need to change the letters. So let me give you this example now. This is the first example. Find the temperature of what? In degrees Celsius when 68 degrees Fahrenheit. Substitute. So look at the formula now. F equals what? C equals 5. F minus 32 over 9. It says this is what in Fahrenheit. So use F. That means F equals to what? Equals to 68. So anywhere you see F here, you put 68 there. So that's going to be equal to what? 68 minus what's it called? 32. So what's 68 minus 32? So that's give you what? 36. So you now say 36 divided by 9. So that is 3 times 4 is 36. So that's going to be equal to what? 4. Then you now multiply that 4 by the 5 outside here. So it's going to be what? 5 times 4. That's going to be 20 degrees Celsius. So when it's 68 degrees Fahrenheit, it's going to be 20 degrees Celsius. This is how to do it. When they give you the Fahrenheit, when you see F there, it means this F. So anywhere you see F, just put 68 there. So you do the subtraction first. 68 minus 32, because it's in brackets. You do it first. Don't forget the order of operation, odd mass. So you do the one inside bracket first. F minus 32, that's going to be 68 because F is 68. 68 minus 32 gives 36. That's why I wrote there. You now divide by what? By 9. Then you want to multiply the answer you get by what? By 5. So it's going to give you 20 degrees Celsius. Any question there?
No.
Okay, so can I give you one to do now? Let me just give you one to do. I'm going to change the Fahrenheit to a different, I'm going to give you a different letter. So I'm changing this to oh, Sorry. And you just hello?
Sorry, I know you're in the middle of the house, but I've been trying to get on it, not loading.
We're there now.
I'm there, it's just rolling and not loading.
Oh.
I'm there. I mean,
Oh,
thank you.
okay, all right. So I'm changing this one to. I will change this one to 86 now. So can you use this formula? Can you find the in degree Celsius now, please? So what's the answer?
30.
So you said what?
30.
Okay. So this is the formula. C equals to 5.
5 multiplied by
Yes.
86
Yes. So
minus 32.
86 minus 32. That gives you what? 54.
54. 5
Yes.
multiplied
So
by
54 divided by 9. That's what? 6. The 6 times 5 is 30. Thank you. That's correct. So when you substitute numbers, it's just what? You're changing what's it called? When you see the letters, you're changing it with what? With numbers. So we do questions on it. Let me just hold on a sec. So I want us to do some practice questions on it before we move on to scattered graph. Just hold on a second. So can you try and do this question, please? The substitution. Done? Just double check. Done? Any question? Are you done with that question?
Yeah.
Are you struggling with it?
Minus
What?
-6.
Okay, you got -6. So let me double check now. So A is what? 4. So you say 4 times what is B? B is 9. So you put it there. Then plus 24 divided by 2 times C. That's 2 times -5. So 4 times 9, that's going to be 36. 36 plus 24, that's going to be 60. So it's going to be 60 divided by -10. That's going to be -6. Okay, thank you for that. So that's correct. So I'm just going to see any other one, the most common one that comes out in functional scale. So I know the temperature, the one we did, normally is a regular question. So okay, yeah, this type of question is a functional scale question. Can you try this question, please?
Okay.
Are you done with it?
Yes.
So what's the answer?
6.
Okay, you got 6. So it says that this is the amount of medicine a milliliter. So to give the child can be worked out by using what this formula. So X is the amount of medicine, A is the adult dose, and M is what the age of the child in months. So A M, that's going to be, so this is 20 months old. Yeah, so and the age is what? M is the age. So you put 20 times the dose is 45. Then you divide it by what? By 150. So 2 times 45, 90. That's going to be 900. This one's going to be like 90 divided by 15. So that's going to be 6. Yeah, 6. Yeah, that's good. That's good. So thank you for that, Gary. That is very good. So, and this one is the final one. Just this final one. Done?
Yeah.
So what's the answer?
Minus 48.
When you say, I don't think that one is right. Okay, I think it's right. So this is this. Yeah, you're right. So the minus is going to be A is 3. So it's going to be 3 times minus 8 times 2. 3 times minus 8 is minus 24. The minus 24 times 2 is go minus 48. That's good. So we go back to our work now. So the second part is correlation, is scattered graph. So let me just show you this part first. So scattered graph is just like they are a good way of displaying two sets of data to see if there is a correlation or a connection. So when you display two sets of data, the good way of displaying two sets of data, just to see maybe they are related. Maybe one affects the other. So for example now, look at this example. The number of umbrellas sold and the amount of rainfall in 9 days are recorded. It's shown on the scattered graph. So this is the umbrella sold. For example now, the rainfall was 3 millimeters. The umbrella sold is just 1. When the rainfall was 2, the umbrella sold was what? What's it called? 10. When it's 4, 25. When the rainfall is 0, there's no umbrella sold. So, and when when the rainfall is 5, the umbrella sold is actually very high here. That's 32. So when the rainfall is 6, the umbrella sold is 47. When the rainfall is 1, the umbrella sold is 8. And when the rainfall is 1 again, the umbrella sold is 15. So if you look at it now, the umbrella sold depends on how high the rainfall is. So, for example, now if the rainfall is very high, it's like there's loads of rainfall. That means the umbrella sold is going to be what? Very high, which is normal. If there's loads of rain, you realize that the umbrella in real life, the umbrella say will increase. So they call that one like similar to like positive correlation. So we look at different types now. So there are different types of correlation. It could be what? Positive correlation, negative correlation, or no correlation at all. If there's no correlation, we look at that one too. So look at this first one now. This number of ice cream sold against what temperature? The number of ice cream sold against what temperature? So if you look at the number of ice cream sold, number of ice cream sold as it's increasing, temperature is also what? It's also increasing. As the number of ice cream sold is increasing, so that means that during summer, when temperature is very high, you will realize that there's these ice cream vans. You start hearing them because what? When it's too hot, people tend to buy more ice cream. Let me just say this. Another person is there. Okay, no one yet. So, positive correlation means what? As one variable increases, so the other variable. So, if the temperature is increasing, the number of ice cream is also what? It's also increasing. So, before we continue, can you give me an example of a positive correlation? Like, as one is increasing, the other one is also increasing. So, for example, now I'll give you an example. The what's it called? The number of classes you attend, if you spend more time studying, your grade will also increase. That's one correlation. The more time you spend studying, the more your grade will also increase. So both variables affect the other. Can I give you an example of one, please? Of positive correlation. When one is increasing, the other is also increasing. Do you know anyone? Anything? Placidia, any suggestion? This Positive correlation means that as one variable is increasing, the other one is also what? Is also increasing. So the second one is called a negative correlation. So graph can either be positive, we know that already. So negative correlation means that what? As one is increasing, the other is what? Is decreasing. So look at this example he gave us here now. He said number of ice cream cones sold, the number of cones sold is decreasing as temperature is increasing. Because during summer, people don't really buy jackets. So the number of coats will be decreasing as temperature is what? Is increasing. So during winter, as temperature is decreasing, you realize that what? The number of coats will be increasing. So let me give you another example. If you put your food, maybe you're not in the freezer, you put it on the table during summer, as time increases, the quality of the food will continue to go down. Like it's going to continue to decay. As time is increasing, the quality of food continues to go down. Another example is your car. If you buy a car today, as time goes on, the value decreases. As time is increasing, the value goes down. So it's going to be depreciating. That's an example of what? Of a negative correlation. So when there's no correlation at all, is what? There is no connection between the two data. When there's no connection between the two data, between the two variables, they call it what? No correlation. Because it's just scattered everywhere. There's no correlation between the two of them. So we can say that what? There's no similarity. There's no connection between the two of them. So you can say this what? This is a negative no correlation. So a line of best fit, this part is also a line of best fit. Line of best fit is a sensible straight line that goes as centrally as possible, that coordinates plotted through the coordinate plotted. So it should follow the same steepness across. So can you see now? So this is what? This is a line of best fit. You draw a straight line again just between those things. So that's the line of best fit. You draw a straight line that matches up the coordinates. Not all the coordinates, at least is central. It's central. So it could be anyone. That's the line of best fit. And it must be a straight line, please. It must be a straight line. Don't start drawing curvy lines. It must be a straight line because they must have the same what? The same steepness. So this is where. Say what?
The straight line.
Yeah.
Does it? Is it? You have to put the lowest and the highest in the straight line or something, or it's just
no, just make sure you pass through centrally.
Okay.
Because for example, now if this one is here and there's one data here, and you are drawing the best line of best fit like this one, no, it doesn't match.
Yeah.
So it has to be just centrally. Yeah. So anyone that does not fit into it is called anomalous results. So it's an anomaly. It's not maybe there's what's it called? There's mistake when they were performing the experiments also.
Okay.
So this is where the question normally comes from. So this type of question, they are always 1 mark question in the functional scale. They are 1 mark question or things like that. They just ask you to draw a line of best fit. So, but sometimes you need to suit off. They can ask you to identify is it positive, is it negative, is it positive, is it negative, or is there no correlation? That's like 1 more mark too. Line of best fit is normally like 1 mark. But sometimes you will need line of best fit to do interpolation. So it's interpolation and words and extrapolation. So this is where the question normally comes from. So let's go interpolation. So for example, now they can ask you to draw in the line of best fit. So they will not ask you to estimate the number. For example, look at this question now. To estimate the number sold of umbrellas sold when 3 millimeters of rainfall. So we use the process called interpolation. The reason they call it interpolation is because what? The data is between range. Because 3, look at what we have been using now. This two have been used, sorry. 3 is between the lowest and the highest. Yeah, the highest probably is 6, and the lowest is what? 0. So 3 is between them, so you can estimate it. So when you draw the line of best fit, the best thing for you to do is that you will now trace it from 3. This you want to estimate the number of watts of umbrella sold. They get in watts when 3 millimeters of rainfall. When there's 3 millimeters of rainfall, so just plot it. There you go. So it's going to be probably 19. That's going to be 19. So so just find 3 centimeters, and you draw the line by going across. You get that from 3, then and then down. And that one is extrapolation. It's when you don't find. It's when the data is not there. So you can use that one is estimates too. So if there's 10 millimeters of rainfall, we could extend the graph. So in this case, maybe probably the line of best fit, this is the final data they gave you. It's over 6. Because this is straight line, you can follow the same pattern and draw it further. Sorry, it's not a straight line. You can follow the same pattern. You can follow the same pattern and draw a straight line. And I say it's like 10. So then you now draw across, then down. So you just need to extend it. If you realize that data is not there, just try and extend that straight line. Then you now trace 10 to it. Because you assume that they are following the same pattern. That's why you are extending the straight line. So you just go, you draw it up, then you go down. That's extrapolation. So the reason why they call it extrapolation is because what's it called? The data, the 10 they gave you is not part of the original data. So if you want to estimate 10 now, just need to extend the graph a little bit because you have assumed that the graph is following the same pattern. So I just want us to do some questions. When you do questions, become clearer. Come in. Okay, nobody's there. Let's pause it. Yeah. So let's just do this question. So what type of correlation is A? Is it positive, negative, or no correlation? Any answer? What type of correlation is A?
Negative.
Negative, yeah. What about B?
Positive.
Positive. What about C?
No correlation.
What about D?
B.
D.
Negative.
Negative. Good. Thank you for that. So, what's it called? This is scatter graph now. So this is scatter graph. Let me see if I can see, draw a straight line and it. Just to see maybe I can see draw a straight line, but come here, let's try and see if I can do it. Oh, get it up and try to send out sheet again. No. Okay, let me just draw the line of best fit. So look at this type of question. I'm not drawing line of best fit, so I'm sorry, don't it's not that straight. So that Dicey spent what? Spent 7 hours revising for test. So what is her score? So you just go to 7. Trace it. Sorry. Okay, sorry. It's not right. So you trace 7. Then you go there. So she's going like to score 70%. That's it. She said Harry's test was score was 30%. How many hours do you think he spent? Is Harry spent? So let's look at Harry. Then was 30%. 30. This 30. He scored 30%. How many I didn't revise at all? Because 30 is 0, innit? That doesn't it didn't revise at all. So I want us to do this to try and do this one. So I'm going to draw a line of best fit for you. So, Tasidia, what's the relationship between these, please? Is it positive, negative, or no correlation?
It's negative.
It's negative, yes. So let me just draw this one. So can you do the question now? So this graph shows the cost of renting apartment and the distance from London. So can you try and do A, B, C? Sorry, I've already done A for you. That's negative. B is the best fit. Estimate the cost of renting apartment from London. So Victor has 1,100 to spend on rent. Estimate how close could he live to London. So if he has 1,100, so it's in between these. Just go there. Just trace it. Sorry. So it should be like 27.
27, yeah.
Yeah. That should be like 27. You should be staying like 27. What's it called? 27 kilometers from London. That's quite far, eh? So let's do this one. So you should draw a line of best fit too. So this one, you just draw it here. Just draw it there. A line of best fit. Then, so for one job, Mr. is needed to replace an expensive part that he fitted quickly. How long will that job take? So for one job, he needed to replace an expensive part that he fitted quickly. How long will it take? So this is the cost and this is the number of hours. So you just want to replace an expensive part. So this is cost scattered across what? So the number of the cost of what? 1.5. How do you get 1.5?
Because they said one job costs 120. So
yes.
If you choose it, it's like 1.5 hours.
So look at this one. Estimate the cost of job lasting for 3.5 hours. So you go here, this 3.5. Then you go up. Then you trace it to this place. So it should be around 200 pounds. So no, around 200 pounds. So 3.5 hours is in between. So a job costs 120 pounds. Estimate the length of the job. It costs 120 pounds. Estimate the length of the job. It costs 120 pounds. So estimate the length of the job. So it costs 120 pounds. Estimate the length. So just say 120. You go there. So it's going to cost 1.5, you know. So already go down one initially.
Okay, but the one you did first, what answer was that to? Okay,
Which one?
3.2 hours. That would be C, isn't it?
3 point what? 3.5.
What you drew before was the answer. The 3.51 is the answer to C. So what's the answer to B?
Okay, it said for one job. So you know it's like 10 jobs now. You get it? So that's what?
Okay, yeah, I can see it. 10 jobs, last 10 jobs.
So that's
5 hours.
yes.
Okay, so we're supposed to divide it by 10. That's the answer to B.
To B, yeah. Lydia, can you hear me? So I'm just trying to see if somebody joined. Lydia, can you hear me?
Yes.
Okay.
Yes, I can hear you. Yes.
Okay. Yeah. Just we still want to do more questions, please, on it. Sorry, one sec, please. So look at this question 2. So a scattered graph shows information about the height and arm span of 10 students is in a school. So they ask you to find what type of population is this. That's going to be positive. So another student has a height of what? Of 150. Estimate the arm span. So I want you to answer this question. So I'm going to draw the line of best fit now. So it's going to like go central. Sorry, just to keep on checking. Like, sorry, I'm just sorry. Use a different color. Doesn't go central here. So there is this. Yeah, if it's just that's the line of best fit. So for 150, Lydia, what's going to be the answer?
150.
155.
What's the question?
Yeah, for 150. And that's near height is 150. What is the arm span? Estimate the arm span of the students.
Arm span is 130.
145.
So 150, just trace it up. Then stops there, then you go this way. It can be 130. Can you see?
145.
Yes.
145.
145, yes. It's 145, yes. So that is it. Negative, all these things are just, these are common questions too that you have to, they normally ask them together. They're going to be like, they will be like 5 questions, like 5 marks in total. You can ask this all the differences. So I just want to quickly do something now. So before we call it a day. So just quickly. So I know Placida submitted homework for assignment for last time. I just saw some correction there. So I want to quickly correct that before I want to put it on the screen now. Put it on my email address. Okay, I have it here. Yeah. So these are some I gave you last week, and I'm just going to because the reason why you didn't send it to my email address because I will have put on the screen, but I think I have the copy of your assignments here. Let's see. So just like the first one is correct, just to ask to find the volume. So just multiply pi times for 3.5 times 3.5 times 11. That one was perfect, was correct. So the second one too equals correct because the volume in times of pi. When it's in times of pi, yeah, was still correct. So I'm really impressed you. What's it called? Let me just try and download it here so that I can annotate it. So it's perfect. You find the radius of this before you could find the volume. So that's good. So your answer is still correct in that. And for this one too, You ask, you said each flower pot is this. So it's how many flower pots can be filled? So it's 50 liters of what? Of this thing. So you find the volume of this first. You got 33,077. So, but one thing is that, let me just double check, maybe your answer is right on that. Yeah, you made a mistake on this one. So, since you got the volume of this one to be what? To be 3,077. That's the volume of this flower pot. So, you have this soil. So, you want to fill this flower pot. How many of them can actually be filled? So, you have to convert this one to liters because this one is in liters. So, you need to convert this one to liters. So, divide by 1,000. So, it's going to be 3.077 liters. You now divide 50 by 3.077. That's it. So you now divide 50 by that. So it's now going to be, what's it called? It's going to be 50 divided by 3.077. So that gives you 16. So 16, you can fill 16 of them.
Mm-hmm.
You can proceed here.
Yes, I'm here. I'm saying
Okay.
it.
Okay. So
I should go back to because this is CM and this is liters. Yeah.
Yeah. So this one is fine. This one is fine too. Yeah, this one is fine. Yeah, this one is fine too. Yeah, when you find the volume of the cylinder, you now have it. So you got this one, okay. So I'm not sure of this one. So 6 times 5 times 8. Yeah, this one is fine too. So this one is let me see. Yeah. So what's the greatest number of CDs? So the diagram of CDs is a circle with radius days. CD has the size, according to rectangular distance. So each sheet is 1 meter long and this wide. So when you say 1 meter long, that's 100 centimeters. Okay, that's fine. So if you work out the greater number of series, you can actually put in the rectangular distance. So you find, not divide, yeah, that's fine. Yeah, this one is what I was looking after. So you guys fuse this. So how many flower pots? It's similar to the one you did before. This one is now 15 liters. You guys, she has what? If each flower pot is shaped as a cylinder with add this, so she has what? 15 liters of what? Of bag of compost. And then she fills it up she fills up flower pot completely. So how many flower pots? You know the mistake you made the previous one? That's the mistake you made again. It's okay. The mistake is just that you didn't convert it. So you have to convert this one to what? To liters by dividing by 1,000. You know you got 1695.
Yeah.
0.6. That's actually what it goes. So you have to convert it. You have to divide by 1,000 to change it to liters. So from there you now divide 15 by that. So that's the same mistake you made on the previous one. So this one is a very common question. So you have to find the volume of. I don't think you did this. Okay, you did this one. I'm not sure. Did you? Oh yeah,
I
you did.
did all the numbers, but I might have missed it.
No. You just didn't print complete. I just didn't see. I can see it now. So not volume. Sorry, it's area. So area is A plus B. When you wrote B, so 12 plus 18, yeah, times 9. Yeah, divided by 2. Yeah, you got it right. So that's what it covers the garden. The grass is sold in bags. That is enough grass. That is enough particular seeds for what? For 20 each bag. See these days. So I'll divide that one by 20 first, then you multiply. Yeah, that's correct. That's good. That's good. So, and this one too. Yes, that's good. It's maths. That's good. Yeah, this is a very common question. Does he have enough? So, let me see. Okay, you finished this thing. That's good. So you already know this thing. 7 kilogram go to 40. So yeah. So we decide these centimeters. So the best for you to convert that one first. You convert it 60 and 32. No, you can't. You have to convert it individually. It's okay. This one is going to be 30. Sorry, so centimeter. This one is going to be 300 centimeter. It's going to be what? 3,600. Oh, sorry. It's 300. This one is going to be 360. So you now multiply them together. 300 times 360 divided by 60. So it's a square. 60 times 60. So what do you get when you do this one? What's 300 times 360 first? Okay, do it quickly so we can wrap it up.
That's 108,000.
Yeah, divided by 3,600.
30.
Yes, so that means that Matthew buys 32. He's having enough.
Okay, but what's the formula you use? Because that means my formula is wrong.
It's not formula is wrong. What you just need to do is that you find the area of this. So you know this one is in meters. So you have to change meters to centimeters. They have to be the same unit.
Yeah.
So
but this would have been length times breadth.
Yeah, that's why I did 300.
Length times breadth
I did
divided
300.
by.
Yeah, I did 300 times what? Times 360. I changed it to centimeters. So that's why you go 1,000 something. You get it?
Okay.
And you have to find the area of this square separately too. That's 60 times 60.
Okay.
So I got the answer to be what? 3,600. So I'll now divide the answer of this one by this one. It's just the same process.
Okay.
I just put that. I put it once. That's the reason why you got so confused. So,
okay, got it.
Yes. So, yes, flaps, just multiply them. So that's it. So, that's that. I'm going to send questions to you too, so you can practice based on like what we read. So, bye.
What did you say?
So I said I'm going to send you questions on the group chat so you can practice more. Just like last week. So, bye.
All right. Thank you. Bye.
Thank you.
Bye. Yeah.